We are almost done with topic 2. We just have like 2 more lessons. But this lesson, I think, is going to take us about 3 days because it's like half this class. Monday's a short day. So like Tuesday, we'll probably be taking the entrance or exit ticket for it. And it's about standard form. So this is another form that we're learning. We learned intercept form, point slope form, and now standard form, which looks like this. AX plus BY equals C. A couple things that we'll be doing with that is solving for X and Y intercepts algebraically, converting standard form to slope intercept form, determining if, and also modeling. So things like that. That's why it's going to take us probably about 3 days. I'm recording right now. I'll post it later, but over the years, I've gathered like a ton of like really good videos on YouTube about all the things that we're learning in this lesson. So if you want to check those out, I used to provide them just because it was like during COVID and kids were learning from home. So that's how I taught it to them, but no reason we can't still use it now. You picked up a worksheet. After today's lesson, I don't know how much you'll be able to do off of it. Maybe just like 2 problems, but I like for you to have it starting day 1 of the lesson, so you can at least do those 2. And then here's the schedule so far. Things might be pushed back or moved forward depending on our needs, but any questions? All right. Couple things. So last week we took the topic 1 test and school policy, is that grades be updated within 7 days of submission. So I'm really hoping to get that done by today. But it's a ton of stuff. It's a lot of stuff that I have to grade by hand. And I don't like taking it home because of like germs and stuff. I just like to keep it here. So I've been staying late working on it, but it's possible I might not get it done until tomorrow. So just be aware of that. So I haven't graded your class yet. I graded my first hour. It scores like some were really good, some were like around 50%. I don't think anyone got like below 50% except for like kids that barely did anything on it. So a lot of the mistakes that I was seeing are just like silly mistakes, like not distributing correctly. So if you see your score and you're like, I want to do better, start looking at the review that I posted last week when we took the test. The Form A is posted in Schoology. You can like study and prepare and then get that done or retake or test corrections included. All right, so just because you get a bad grade doesn't mean you get to keep that bad grade. You can always improve it. Any questions about that? All right, so we have our note sheet that you picked up today. Look for the vocab section and fill this out. So it's on the page where there's like thought bubbles, like at the top. We're going to fill out some vocab. All right, so standard form is AX plus BY equals C. All right, so unlike the other 2 forms that we learned, you know how I told you, you can kind of use the name to figure out what you need. So like for point slope form, what 2 things do you need? Your slope and a point. What about for slope intercept form? What 2 things do you need? Your slope and y-intercept. So standard form doesn't really like tell you things like that because it's usually just like given to you, or it's just like a form that you write things in. So like standard, I think like ABC, right? That's like the standard alphabet, I guess you could say. That one's just like the oddball. All right, it doesn't really tell you what you need. So this one is just ax plus by equals c. Now I'm gonna have you write this part down or make arrows to it, highlight it, something. But the only letters that get replaced with numbers are going to be A, B, and C. All right, X and Y will still be there, just like how they are in all the other forms we learned. That A, B, and C are all numbers. All right, and for true standard form, A must be positive. So if you're like converting something from like slope intercept form to standard form, I'll double check to see if that's even on the test and let you know. But if you're told to write something in standard form and say like this is what you have, negative 4x plus 2y equals negative 3, then it's really not in proper standard form because that A number is negative. So like what's a way to convert something from negative to positive? So I don't want you to add anything, but that's a good thought. Multiplying works. Usually we say like dividing, but yeah, multiplying does work. It's basically like multiplying or dividing everything by -1. If you do it to every single thing, you're not really changing the value, but you are changing all the signs. And when I do that, the A is now positive. So it's now 4x minus 2y equals 3. All right. So you just divide it by -1, get that A positive. That would be like the true standard form. That makes sense? So A, B, and C are numbers, and A must be a positive number. If it's not, make it positive. All right, then we have X and Y intercept. So here's like the standard definition. I'm going to give you another one. So it's where the line crosses your axis. And same with your Y intercept. It's where it crosses your Y axis. But I'm going to give you an additional definition that I just want you to squeeze in there. For your x-intercept, it's also when y equals 0. All right, your x-intercept is also when y is equal to 0. So think of like a standard like coordinate plane. If I have an x-intercept, where is it on this coordinate plane? Is it on the vertical line or the horizontal line? On the horizontal line. So let's say it's like right here. Any point that is on that x-axis has a y value of 0. So when I say your x-intercept is when y equals 0, well, let's say this is the 0.30, that y value is 0. If I do it like over here, let's say this is -30, the y value is 0 again. At the origin, 0, 0, y value is 0. So anytime you see where the y value is 0, that's your x-intercept. So then the y-intercept would be, can anyone guess? When x is 0. So if I'm thinking of putting, like, so my y-intercept would be on my y-axis on this vertical line. All of the points on this line have an x value of 0. So like if I do this point, let's say it's 0, 1, right? 1 is my y-intercept. That's x 0. Let's say I'm down here. It would be like say 0, -8. Well, -8 is my y-intercept because x is 0. All right, that'll be helpful later, but just have those definitions in there. Any questions? All right. So then here's here's some modeling that we can use standard form for. It kind of is helpful, like if you think back to your first test when it had you model stuff, it's kind of the same thing. So we had Hannah will spend $150 on music festival tickets. Reserved seat tickets cost $25, and general admission tickets cost $10. So how can you represent the situation with a linear equation? All right, when we say linear equation, so we're thinking of an equation that makes a graph that either looks like this or like this, so like a straight line. Our mind usually goes to y equals mx plus b. All right, but when we're like making the equations to solve, you'll notice that it usually looks like standard form. So fill in these boxes on your paper. All right, if we're trying to set this up to figure out like how we can model how much she's spending, like how much total does she have to spend? $150. So usually anything that's a total or like a budget, something like that, is next to an equal sign. So you'll see that over here. All right, her total budget is $150. So we let that be equals 150. All right, and then when we're talking or even just thinking about the cost of these other tickets, like let's say I wanted to do 2 reserved seat tickets and they cost $25. How much am I spending if I'm buying 2 of those tickets? $50. How much would I spend if I wanted like 10 of those tickets? $250. And what operation are you doing to figure that out? Multiplication. Now, does it say how many of each ticket that she's buying? So that's why they represent it as an X. All right, so normally like 25X, where X represents your cost of reserved seat tickets. And then we also have something else in there. The $10 general admission tickets, which again, you know, is multiplication. 10 times however many of those tickets she wants to buy. And then just throw it together, and now you can model it. And doesn't this look like standard form? Yes. All right, so if you see one like on your topic 2 test about modeling or even on your entrance ticket, just think like what operation's being done and make your equation. It'll probably look something like this. Questions? All right. So let's look at this compared to slope intercept form. So when I'm looking at it in standard form, so I'm going to go to this next page, which is like the bottom of your page, where it says let's compare. So here's my standard form that we created. And here is it written in slope intercept form. So notice like in slope intercept form, what is isolated? The y, right? And in standard form, the y is not isolated. So if I wanted to just convert it to slope intercept form, which you will need to do like when you need to graph stuff, you're going to want to isolate the y, just like how it is over here. So let's do that. I'm going to scroll down and do it down here. So, and this also helps with those literal equations that we learned in the last unit too. But if I want to convert this to slope intercept form, means we get the y by itself. So how do I do that? What do I get rid of first? The 25x or the 10? And how do I get rid of it? Good, so we're gonna subtract it on each side. On the left side, what happens to the 25x? Cancels, so we have 10y. And then on the right side, are those like terms? No. So I'm actually just going to write them next to each other. So it's 150 minus 25x. Then how do I get the y by itself? Divide by 10, good, because that's opposite of multiplying by 10. And when you do that, make sure you're dividing it from each term. All right, because really you're dividing this whole thing by 10. On the left, it cancels out. We have y equals, what's 150 divided by 10? 15, and then negative 25 divided by 10? Negative 2.5x, and then if I bring down what we had up here for what they said slope-intercept form is, isn't this saying the same thing? Yes. The only thing that I would maybe like change is just the order of these two things. All right, so normally like at this step, when you are just rewriting them, I'll usually tell my students to write it as negative 25x plus 150, just so that it looks more like slope-intercept. All right, so you're not changing the signs of either of them. The 25 is still negative, the 150 is still positive. We're just changing the order. So like if I change this order, now the exact same. All right, and that's what we're going to be doing today. Any questions? All right, so in slope-intercept form, you can clearly see like what your y-intercept is, what you're having to spend, and then like what it's decreasing by. Over here, you can clearly see like the cost of each ticket and her budget. So, you know, that's like the differences there. All right, so this will go under the teacher example on the back side. Try your best right now. All right. So here's the teacher example. What's the graph of 3x minus 2y equals 9? Now, did I tell you like, you know, this number is your y-intercept, this number is your slope? Like, can you tell that from standard form? No. So what form can you tell it from? Slope-intercept form. So in order to be able to graph this, step 1 would be to convert standard form, or you could just say convert to slope-intercept form. So convert to y equals mx plus b. All right, convert to y equals mx plus b. And if you want to add this part by isolating y. All right, because what's by itself in slope-intercept form? The y. So what we need to do here is get the y by itself. So to get the y by itself, what do I need to move first? The 3x or the 2? 3x, always move what's farthest from it. So how do I get that to be 0? Subtract it from each side. Cancels out on the left side. On the left side, what do I have remaining? negative 2y. So don't forget that negative. Okay, negative 2y. On the right side, what do we have? Good. So if you were thinking 9 minus 3x, that's the same thing, but just try to get in the habit of writing the x term first. All right, we're not changing anything other than the order. So the 3x is still negative, the 9 is positive, so that's why I wrote plus 9. Good there? Now what's opposite of multiplying by 2? Or negative 2, no. So dividing by negative 2 on each side, which means make sure you do it to both of these terms on the other side. All right, then we have y equals, is the slope allowed to be a fraction? Yes. In fact, it's probably better that your slope is a fraction instead of doing 1.5. Because do I want to go up 1.5 to the right one? That might be harder to keep track of, right? So I'm going to leave it as a fraction. But what happens with this double negative? So it's a positive 3 over 2. So that double negative x. And then is it all right if our y-intercept is a decimal? Yes, and that's probably easier to estimate on the y-axis anyway. So what's 9 divided by negative 2? Negative 4.5. Any questions? All right, so now that it looks like slope-intercept form, I can actually graph it. So if you're writing down the steps, step 2 is to graph. And we've already covered the steps for graphing, but what do we always graph first? Your y-intercept. So if it's negative 4.5, where should it be on this graph? On the upper part or the lower part? Good. So from your origin going down 1, 2, 3, 4.5. And then use your rise over run to find your next point. So we're going up 1, 2, 3, and to the right 2. Remember, it's like in that halfway mark, so we'll be right here. 1, 2, 3 to the right 2. Then again up 1, 2, 3 to the right 2. And connect the dots, make your arrows. And sorry, I'm really bad at connecting the dots. All right. Any questions? The only thing I would suggest with these, so here's like a cool way to check your answers, is to do so using Desmos. So if you want to if you don't have your Chromebook out, I suggest timing it out. But if I go on to desmos.com to the graphing calculator, I can type in what my original problem was. So it was 3x minus 2y equals 9. All right, and makes a nice little line over here. And what I can do is type in what my answer is. So y equals 3 halves x minus 4.5. Now, aren't they the exact same line? Yes, so that means I graphed it correctly. If it was off, even just by like a sign, like maybe I put plus 4.5, all of a sudden they're different, right? So even a small thing like a sign can change it. So this is just so you can check your answer. I mean, on a test, you still have to like show your work, that's part of the points, but you can at least know that you're doing it correctly by plotting it in Desmos. Questions about that? All right, so then let's do the class example and we'll go a little faster. Anyone still on this page? All right, so here's the class example. Using the steps that I told you, what are we trying to do to this equation? What do we want it to look like? We want it to look like slope-intercept form. So what do we need to isolate? The y. What do I get rid of first? And I get rid of it by subtracting it from each side. On the left, it cancels out. So on the left, all I have remaining is -4y. On the right, are these like terms? Can I do like -27? No, they're not like terms. So how do I write it? -3x minus 24. Keep going. One more thing I need to do to get the y by itself, which is, so do that on each side. So make sure that you do it to both terms. And we have y equals, what's the slope? 3/4. Is it negative? No, because we had a double negative, right? So notice that change. Double negative makes it positive. And then -24 divided by -4 is 6. Is it going to be plus or minus 6? Good, because it became positive. All right, does it look like slope-intercept form now? So we're going to graph it. Plot your y-intercept first. What's my y-intercept? 6. So it should be right here. And then my rise over run, am I going to go up or down 3? Up. So from that point, go up 3 to the right 4. All right, and then we ran out of space over here to go up 3 again to the right 4. So I might have to work backwards, like sometimes that happens on your test. So do you guys know how to work backwards? You just do the complete opposite. So this tells me to go up 3, right 4. If I need to plot a point to the left of this point, we do the opposite. We go down 3 to the left 4. All right, and it still lines up. You can double check it. You're still going up 3 to the right 4 from this point to that point. So we can make our line. Does that make sense? All right, I only recommend doing that if the graph is cut off like on a test. Otherwise, just always go to the right. All right, so here's the student example. Ready for it? All right, so I'm gonna switch this here. If you're taking notes. All right, here's the student example. Try it and then check your work using Desmos. All right, if you converted it correctly, your equation in slope-intercept form would be y equals -4/5 x plus 2. All right, and then your graph based off of slope-intercept form. Y-intercept is 2, so that's here on the positive side of your y-axis, going down 4 to the right 5, and I think I might have moved that dot. Hold on. 1, 2, 3, 4, 5. No, we're good. All right. So why did I go down 4? Because your slope is negative, right? So that affects your rise. Should have gone down 4 to the right 5. Questions? All right, now if you checked your answer using Desmos, what I highly recommend, especially on like an entrance ticket. So y equals -4/5 x plus 2 is our answer. And then written in standard form, it was 4x plus 5y equals 10. So they should overlap each other if I did it correctly. All right, any questions? Okay. Since we still have time and Monday's a short day, I'm gonna kind of lean into something else. I'm gonna pass out the other part of your notes. Any questions though so far? All right, so let me pass this out for a second. All right, so think back to those definitions that I had you write for x and y intercepts. They were like alternate definitions. So if I'm telling you to find, or what is the x-intercept, what was that definition that I told you? It is where the line crosses the x-axis, so we should expect it to be on the horizontal line. And I also told you it's when y equals 0. What about the y-intercept? What was the other definition I told you? It's when x equals 0. And then just knowing that, I can actually figure out my x and y intercepts and then graph the line based off of that, instead of like converting it to slope-intercept. So let's start with our x-intercept. Our x-intercept is when y equals 0. So here's my equation, but instead of writing y, I'm going to plug in a 0. All right, because if the definition of x-intercept is when y equals 0, by plugging in a 0, I can solve for the x. Does that make sense? So solve for x. Simplify this first. What's 4 times 0? So it's really x plus 0, which is just x. So actually, I'll write that in. And then yes, it just becomes x. Now is the x by itself? Yeah. So that means that my x-intercept is 8. So that means your x-intercept is 8. So on my x-axis, I'm going to put a point where there's the 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. All right. Now find the y-intercept and think to your definition. The y-intercept is when what is 0? So I'm going to put in a 0 for the x. Write everything else the same, plugging in 0 for the x, and simplify. So start simplifying. What's 0 plus 4y? So 4y equals 8. Opposite of multiplying by 4 is, so do that on each side. And what's my y-intercept? 2. So you get y equals 2. That means our y-intercept is 2. So then put a dot on the y-intercept of 2. And then connect your dots that way. Oops, I'm really bad at drawing straight lines in there. Okay, really bad at drawing straight lines, but you get the point. All right, now we're using x and y intercepts to figure out our graph. Does that make sense? All right, we'll do more with that on Monday, but since it's a short day, I wanted to fit that in there.